Welcome back. We're going to talk about absolute extrema over a closed bounded region. Well, first of all, let's talk about what closed and bounded means. Uh, Here's a circle, and if this is x squared plus y squared less than 1, for instance, then this would be all the points inside the circle, but the dotted line indicates we don't include the boundary. That's what's called an open region. Boundary not included. Now, on the other hand, if we were to say meow, x squared plus y squared less than or equal to 1, then we, of course, would include the boundary and everything inside, and that would be a closed region because it includes the boundary. Now, a bounded region, if you consider, for instance, this region, there's x, there's y. Now let's suppose that's 2 and that's negative 2, and this is basically y between negative 2 and 2. X can be anything. X can go off to infinity and beyond, or to negative infinity and beyond. This is a closed region, boundary here, but it's not bounded. Okay, it's infinite in length. Okay, so what does the word bounded mean? Okay, it's a topological term, but the best way to think about bounding is you can bound it with some sort of shape. So, for instance, that's bounded. Okay, I can do that. I can draw a perimeter around it and enclose it. And so that's a bounded region. You can come up with a more complicated region, or a more complicated definition, but we're not too concerned about that. Just use the obvious definition. You could say finite. It's finite in size, so to speak. It doesn't go off to infinity. Very easy to find absolute extrema, and by absolute I mean absolutely the largest value and the smallest value. As long as this is a continuous function on this region, there exists an absolute maximum and absolute minimum. If this is not bounded, of course, the function could continue on to infinity. It wouldn't have a maximum. If it doesn't include the boundary, well, you could have an asymptote, okay, where it approaches the boundary, goes to infinity. If it's discontinuous, you could still have something going to infinity. In fact, it's continuous, and we can have some finite region, including the boundary. Our only choice is to have an absolute maximum. And here's how we're going to do it. First of all, we're going to find critical points on the interior. Now we have the region negative 2 to 2 and negative 2 to 2. That's what's called a Cartesian product. We're basically saying x is between negative 2 and 2, y is between negative 2 and 2. And I'll draw the region over here for reference. We will need it. Okay, let's draw it over here. There's negative 2 to 2, negative 2 to 2. Okay, if it were a circle, we'd have to use an equation. X squared plus y squared less than or equal to 4. That would be a circle. But this says x can be anywhere from negative 2 to 2, y can be anywhere from negative 2 to 2. Okay, so we're going to find an x partial, 2x minus 2 equals 0. X equals 1. Going to find a y partial. set it equal to 0. Okay, where's 1, 0? That's right here. That's inside this region, so we're good. Had this been the 0.50, guess what? It would be out here. We just ignore it. Next, we're going to make an XY chart and keep a finite list. Here's my grandson made a portrait of me. You can see the remnants of it. We're going to make a finite list of possible candidates. Well, we have 1, 0. That's our first choice. We need a third column, f of xy. And you can plug in 1, 0. Plug in 1 here, 0 here, 1 here. 1 minus 2, negative 1 plus 0, negative 1. And now we're going to check the boundary. As far as the boundary is concerned, you can actually include the corners right off the bat. So for instance, we have 2, 2, 2, negative 2, negative 2, 2, negative 2, negative 2. And you can substitute at 2, 2. We have 4 minus 4 plus 4 is 4. 2, negative 2, y is negative 2. Actually, that's going to give you 4 as well. And negative 2, 2, negative 2, 2 gives you 4 plus 4 plus 4 is 12. Negative 2 ends up giving you 12 as well. So far, the absolute minimum is negative 1, the absolute maximum is 12. Now what we have to do is check all these boundary points. And this is really max, min, and a closed interval. That's something you did in Calculus 1. We're going to have max, min, and a closed interval here, 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 and here. 4 of these problems, although we included the endpoints in the beginning. So let's talk about the top up here. Now you'll notice what happens is y is equal to 2, and x goes from negative 2 to 2. Since y is equal to 2, you can plug that in here. F of x2, okay, is equal to x squared minus 2x plus 4. And the x partial is equal to 2x minus 2 equals 0. X equals 1. Okay, so we have x equals 1, y equals 2. Okay, is that on here? Let's see, x equals 1, y equals 2. That's right here. Okay, if it were out here, we'd ignore it, but we're good. 1, 2. Plug in 1, 2, you get 1 squared, 1 squared, 1 minus 2 is negative 1, negative 1 plus 4 is 3. Okay, it's a local extrema right here, but it doesn't beat some of these other points. And now you can do the right side. Okay, doesn't matter what order you do this. And on the right side, x equals 2. Okay, you can plug in 2 here, 4 minus 4 is 0, and plus y squared. So you get f of 2y is y squared. 4 minus 4 disappears. F sub y is equal to 2y, set it equal to 0. Y equals 0. So it looks like we have x equals 2, y equals 0. That's right here. Okay, that's a new point. 2, 0. If you plug in 2, 0, we end up getting 4 minus 4 is 0 plus 0 is 0, 0. Not a min or a max. Doesn't beat that, doesn't beat that. Okay, and then we could do the bottom Let's see what's going on at the bottom. Y equals -2. X goes from -2 to 2, and since y is -2, you can plug that in here. F of x comma -2 is equal to x squared minus 2x plus -2 squared is 4. Fx x -2 is equal to 2x minus 2 equals 0, x equals 1. And so we have x equals 1, y equals -2. We're running out of room here. Okay, 1, x equals 1, 1 minus 2 is -1, -1 plus 4 is 3. Nothing profound there. And then we want the left side. And on the left side, x equals -2, right? So okay, so we can plug in -2 gives us 4. Plug in -2, it's 4. 4 and 4 is 8. Plus y squared. And f sub y, looking for critical points on the interior of that line. -2y is equal to 2y. Set it equal to 0. Y equals 0. And so we have a point, I'm kind of riding low here, -2, 0. That's right here. So -2, 0 ends up giving us 4, and 4 is 8, and 0 gives us 8. Well, and guess what? There's the absolute minimum, there's the absolute maximum. So I'll leave it to you to state. We have an absolute minimum of -1 at the point 1, 0, -1. We have an absolute maximum of 12 that occurs in 2 different places. Okay, and that's absolute extrema on the closed bounded interval. So